Hello to all from the sunny California. Let's see what we have today. Let me bring my camera down here. Well, I have several things. One thing I have to say it's about the new firmware changes. Sorry for the shaking of the camera. But before that, there are some other things like to explain what's the difference between the servo motors and the AC motors and the DC motors. Just quickly, just from perspective of what kind of signals they require. So let me see. I have some cards here that I prepared to try to visualize these. Like this card actually is for both AC motors and DC motors. They're similar how they work. So except most of the VFD motors for AC motors, they require analog signal to drive them, which is, for example, this is actually the position we get from the software we're using for the motion sim. I visualize like that, usually just values. It's not like a wave or analog, it's digital values that goes up and down. It positions the motor for the platform in certain positions. So for example, for analog, since this is for speed, when it moves, for example, to a position, the motor accelerates, then stops when it reaches the position. When you change the direction, accelerates again to the other direction. You can see down here the direction for that, the change. So it changes the direction, it changes again, and so on. So every time it has to do a new position, it has to change the direction of the motor too. And of course the speed of it, that's analog, goes up and down. Now the pulse width modulation, it's almost the same except using pulses with different width. That is, for example, I have here set up, I connected the pulse width modulation module, not the analog, and you'll see here what happens when for example, I change the position of the feedback manually. You can see that's in the middle, all the way down, goes up, it goes up again, right? That's not by mistake, that's how this works, because the motor has to follow the sensor. But this is actually how this works, like speed. Like when it has low waves, it's like low speed. Then you have to accelerate to make bigger speed. Bigger speed, it's like it's going up, like this one. That's the speed that the analog control does. But it's a little more like pulses type. You can see if you join this. The length, the full length, you can join it and try to calculate the distance. You'll see that it forms like a little waveform. I draw it over it. That's not what it is actually. So you can see that's actually following this. So the next card, that's for the pulse burst mode. That's for servo motors. These work a little different. They usually have a pull system that allows them to step into specific positions. Like if you choose to send a step for 100 pulses, it will move exactly 100 steps. Now how much is that step? You have to define that in the servo motor itself. That depends on the resolution of the servo motor, how much steps, what 100 steps mean for the servo motor or the servo engine. So to show you quickly how this works, for example, when it accelerates, it sends a burst of pulses that mean that for example, to do this acceleration, it will need to go to this position, it will need a certain amount of pulses. Then once it's there, it won't send that many, probably less than that. Then when you have to move down, sends more pulses. And when it's almost calm, for example, I'll show you here, for example, in the red, when it's calm, it doesn't need to send impulses because it's already in a position. Or for example here, it doesn't send any because it's flat. When it does a little bump there, to move a little down again, it performs pulses. Now you can see I forgot to put the direction there, but yeah. So you can see every time it needs to know what's direction and how many pulses to go there, and then changes direction and how many pulses. So that's pretty much how these work. Now I'm gonna the changes I did on the AMC was to add this mode for the pulses, so I'm just using the LCD menu for now. I haven't had the chance to do the configuration manual for it, like the program, like Fabian, so it doesn't have right now the configuration screen yet, but it will be there. So let me see, let me change that. Actually it's the last two settings. I just named them clear path motor and CLP parameters. Right now it's disabled. Let's enable it. The burst mode is number 3. Save it. Let's go back to the parameters. I'll show you in a moment what this means. I'm gonna probably need to change the frequency, maybe not. Let's see. Calibrate the camera. So what I was talking about, the resolution of the motor, actually this one you can set how many pulses total you're gonna use. Okay, the camera is not focusing. Okay, so you can either set it for high resolution, so the total travel of the motor, it will be 16-bit. Then you can have it less. I mean, some of the servo motors don't need that much pulses. Usually it's okay to use about 4096 or less. You can go down to 2104. Okay. Alright, so I'll leave it here. So let's see what happens with the frequency. The frequency, it's how big it will be, this thing, the pulse frequency. So you can set it very high, 127 kilohertz, or very low, 21 kilohertz. I'll leave it on 21 kilohertz so you can see it on the oscilloscope. There's the delay for the change of direction. That's nothing we need right now. So let me go back here. I'm gonna set the program to just do some clicks up. I don't know if we can. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we can capture some. Okay, so it's going up, and let's see if we right. So this is the pulses we get. This is what we get since I have this moving up in constant speed. Okay, so I have set the modern pulse burst mode, so let's see what the resolution does. I'm gonna actually start moving it, and you can see by increasing the resolution, for the same speed you send more pulses than for less. Okay. Now, when you change the width, let me zoom this a little bit. You can see the difference. That's for 21 kilohertz. You can see that there in the oscilloscope. Does I increase? Okay. Does I increase the frequency? So it's the same frequency there. The pulses get closer and closer. They're the same pulses, but it transmits faster. So if you have servo motor that can handle this kind of pulse frequency, you can use it. Okay. Now let me go back. You can see the resolution there. So you can increase the resolution and increase the frequency, and there you have it. Now let me change the trigger to auto. You can see what that means. Now you don't see them often because it's hard to capture. Maybe I'll decrease the frequency so you can see it. Okay. Now you see it setting the pulses so slow because that's the rate I have set on the program. You can see how often they change. Okay. Now if for some reason I want to change it to go faster, let's see, just put it here and do it manually. Let's see, 33 microseconds now. Okay. So anyway, this is how this works for the pulse burst mode. You just need to have two lines, one for pulses, one for direction. So you can see here when I have for the pulses it's the out one, if you can see it, and that's for the direction, and the pulse width modulation is for the pulses. So I'm just gonna put it on the direction one. Let's see what happens when I change direction manually. Time frame. change the direction there. See, if I keep pushing to the same, moving into the same direction, it stays there, but as soon as I change it, so this is the one you need, the other one's the pulses. That means how many pulses does it need. Example, I can bring it closer so you can see what that does. Down. Example. That's a little bit of pulse there. Let's do a big change. That's there. Normally you can see it gets even bigger for bigger distances, but for small distances Alright, so that's in a short how to set up the pulse burst mode for Servo Motors. I hope to have some more documentation on just what this means, for example, but like I have actually another card that may help on that. Like, for example, most of the cases you'll have a servo motor that, for example, to do a full resolution, this one for example has 600 pulses. The belt has a belt or a reduction gear that it needs 2.5 rotations of the actual motor to move from point 1 to point B. So what that means, you multiply the pulses you have, and then you say, okay, I need 1,500 pulses. So you can go there and change that, the resolution, all that you need. Well, that's all I have for now, but I can decrease it, but that's just an example. Usually it's more than just 600 pulses for the revolution of the motor. That's why this one can go up to, let's see, 65,000, 16-bit. Okay, something else you have to see, for example, it's I'm setting pulses. I'm gonna change the direction, go down so you can see, like 10 ticks. That's a frequency. I send it from here, so it's just a constant speed of 6 Hz. That's how many ticks I'm setting, how many pulses. That corresponds to the pulse burst mode, how many pulses it will send to move. So that's for constant speed. So you can see here actually the 10 pulses there. If I decrease it, let me see, I'm gonna decrease it here so you can see it here decreasing as well. 3 pulses, if you can see it there. I'm gonna increase it. This is for 15 pulses, 20 pulses. So if I decrease the resolution here to half of it, I have only 10 pulses there, right? And if I decrease it more, so you can see after a while I get only 1 pulse until it fills this number, so it's rounding. So you can see it's losing some of the resolution, but that depends on the motor. The total amount of data you send there, it will still be going, but it won't have that much of the resolution. Usually resolution like let me see, 4096 would be 95 would be good enough, and then you're gonna have like about 100. Let me increase it there to 100. Okay, that's 100 pulses, 100 ticks anyway, but it translates to about 5 pulses here, right? Yeah, so you can see increase and decrease it. I'm suggesting using about this resolution because it will be faster, but you can always use the bigger one if you're doing slow motions. Let me change. You can see here the change of frequency. I'm gonna use, let me zoom in to this one. This is 127 kilohertz. That's 100 kilohertz, 84, 72, so on. That you can change that depending on what your servo drive can handle on speed. Yep. So I hope this helps understand how this works. Well, thanks for watching, and from sunny California, that's a little bit hot for Christmas holidays. Have a good year.